let us discuss about the relationship between zeros and coefficients of a polynomial. Let us start with linear polynomial. Already we have seen previously that p of x, if it is equal to ax plus b, the relation between coefficients and zeros. Here for a linear polynomial we have only one zero, and to obtain that zero directly we have formula that 0 of ax plus b is equal to minus b by a, and we mentioned formula also there. Well, this here minus of constant term by coefficient of x. This is the formula directly to find 0 of a linear polynomial, which we have discussed already. Now let us see the relation between zeros and coefficients of quadratic polynomial. Generally, quadratic polynomial general form is p of x is equal to ax square plus bx plus c. And now let us consider a monic polynomial. What is meant by a monic polynomial? Monic means if the coefficient of degree term, that means this is called leading term, coefficient of leading term or leading coefficient. If this leading coefficient is 1, then the total polynomial can be called as a monic polynomial. This can be for quadratic or cubic or any polynomial with nth degree. Suppose a polynomial with third degree, degree 3, is having leading coefficient 1, then it can be taken as a monic cubic polynomial. Here, as this is quadratic, we can say as monic quadratic polynomial. So if the polynomial which we have taken is a monic quadratic polynomial, then we can express, see, x square plus bx plus c, like this we can have the monic polynomial. This can be expressed as x minus alpha into x minus beta, where alpha comma beta are its zeros. If alpha and beta are zeros of this particular polynomial, and if this is monic, then we can express directly the expression x square minus bx plus c equal to x minus alpha into x minus beta. Let us see with a small example. Suppose we have x square minus 5x plus 6. Is this a monic polynomial? Yes, it is, because x coefficient of x square is 1. So this is a monic polynomial. And here, what are the zeros of this polynomial? Let us see. While finding zeros of this polynomial, first we factorize this polynomial. How to factorize? Already we know the process. Here 6 is the constant term. 6, if we multiply with the coefficient of x square, 6 into 1 is 6, and 6 can be factorized like this, 2 into 3. As the middle term has negative sign, minus 2 and minus 3 we can take. So x square minus 2x minus 3x plus 6 we can take, which can be taken like this. Here from these two, x if we take common, x minus 2, and from these two terms minus 3 if we take common, x minus 2 is left. So x minus 2 is common again from these two, so we are left with x minus 3. So here this product now will be equated to 0 to get each of the zeros. That means here 2 and 3 are only the zeros of the polynomial. So x square minus 5x plus 6 directly can be expressed as x minus 2 into x minus 3. X minus 2 into x minus 3. Now, suppose if it is not a monic polynomial, then it will be like ax square plus bx plus c only. Now, if for this polynomial alpha comma beta are the zeros, then it can be expressed as a of x minus alpha into x minus beta actually. This also we can verify with an example. Let us take an example of 3x square plus 4x plus 1. 3x square plus 4x plus 1. And here this, if we factorize, how can we have the factors? 3x square, 3 into 1 is 3. So 3 can be factorized like this, 3 into 1. And 3 plus 1 is 4, which is the coefficient of middle term. So directly we can take plus 3x plus 1x plus 1. So here 3x we can take common from the first two terms, which results in x plus 1. Here 1 is only the common factor for these two. So 1 of x plus 1. So here x plus 1 is common from these two. So 3x plus 1. Now here if we equate them to 0, what happens? You see, x plus 1 into 3x plus 1, if we equate to 0, x plus 1 equal to 0 or 3x plus 1 equal to 0. So x equal to minus 1 or x equal to minus 1 by 3. These two are the zeros actually. That means while expressing in this way, we have to write x minus alpha. Alpha means here minus 1 by 3 into x minus of minus 1. So x minus alpha into x minus beta we wrote. That means here x minus of minus plus 1 by 3 of, here also x minus of minus plus. Now it is nothing but x plus 1 by 3 of x plus 1. But here this x plus 1 by 3 of x plus 1, let us multiply. This is 3x plus 1 by 3 after LCM of x plus 1. Now these two, if you multiply, 1/3 of 3x into x, 3x square, 3x into 1, 3x plus 1 into x, x plus 1 into 1, 1. So this is nothing but 3x square plus 4x plus 1 whole by 3. So the product of x plus x minus alpha, this is actually x minus alpha, this is x minus beta. So x minus alpha and x minus beta is nothing but the polynomial divided by 3 here in this case. That means we can consider 3x square plus 4x plus 1 as equal to 3 times x plus 1 by 3 of x plus 1. This here we can clearly understand that it is 3 into x minus of minus 1 by 3 into x minus of minus 1. And we can express in this way, x minus alpha into x minus beta. So because here minus 1 by 3 and minus 1 are the zeros of this particular polynomial. Those we have represented as alpha and beta for a general polynomial. So if we consider general polynomial, that means a general form of a polynomial ax square plus bx plus c with zeros alpha and beta, we can express this as a into x minus alpha into x minus beta. So if this is not a monic polynomial with some coefficient of x square, with some non-zero coefficient of x square other than 1, then this can be written as a into x minus alpha into x minus beta. Now let us see some relations among these coefficients and zeros. Therefore here we can write this as ax square plus bx plus c divided by a is equal to x minus alpha into x minus beta. This is nothing but ax square by a plus bx by a plus c by a is equal to x minus alpha into x minus beta. So this is x square. Can we express this as minus of minus b by a? Plus we have, plus I am writing as minus into x plus c by a. And this here on RHS, by multiplication of x minus alpha and x minus beta, clearly we can get x square minus alpha x minus beta x plus alpha beta. Minus into minus becomes plus here while multiplying minus alpha and minus beta. Therefore, here we can clearly see that this is x square. From these two, what can be taken common? Minus x we can take common. Minus we can take, x also we can take common. Then alpha plus beta is left. Plus alpha beta. So by comparing the coefficients of these two expressions on LHS and RHS, we can get, here see x square coefficient is 1 on both sides. So if we compare also, they are same. Next, the other coefficient, x coefficient, that is alpha plus beta, minus of alpha plus beta we have. Here minus of minus b by a we have. So without minus, if we consider both, alpha plus beta is equal to minus b by a, and alpha beta, which is constant term, if you compare, that is equal to c by a. That means here alpha plus beta is nothing but sum of zeros. Sum of zeros is equal to minus b by a. So this is a formula, for sum of zeros, minus b by a. And here this is product of zeros, alpha into beta. That means it is product of zeros is equal to c by a for a general quadratic equation in the form of ax square plus bx plus c. So if you take general form of a quadratic polynomial ax square plus bx plus c, for this formula for sum of zeros is minus b by a, and formula for product of zeros is c by a. Now let us take some examples and verify whether these are correct or wrong. Always. That means we'll take some examples. For those examples, we'll apply these formulae. Even we'll find zeros also in other method, and we'll verify whether this is satisfying original zeros or not. That means sum of zeros directly, if you find that is same as minus b by a or not, we'll verify that. Let us take an example, x square minus 2x minus 8. For this polynomial, let us apply these formulae, and by applying these formulae we can obtain sum of zeros and product of zeros, and after factorization we'll obtain two zeros of this polynomial. Those two zeros also we can add, we can multiply to tally with this. So first let us take the formula. For taking the formula, first this must be compared with the general form of quadratic polynomial. What is the general form of a quadratic polynomial? That is ax square plus bx plus c. Now by comparing with these, what are the values of a, b and c? A is equal to 1, which is the coefficient of x square. B is equal to minus 2, c is equal to minus 8. These are the values of a, b and c for this particular polynomial. Now what can be the sum of zeros here? Sum of zeros is minus b by a. This is the formula. So minus b is minus 2 here. B means minus 2. So minus of minus 2 by a is 1. So answer is 2. Now product of zeros. That means here this is alpha plus beta. Product of zeros you take. What is product of zeros here? C by a. C means here minus 8 by a is 1. So this is nothing but alpha beta. So alpha beta we got as minus 8. Alpha plus beta we got as 2. Now let us find the values of alpha and beta. As this can be factorized easily, we can find. Now how to factorize this? X square minus 2x minus 8. 1 into minus 8 is minus 8. Minus 8, factors of minus 8 we have to take, and those factors if we add, we should get the coefficient of middle term x. That means minus 2 we should get. So for that I am taking 4 into 2 and minus I am taking for 4. 4 into 2 is 8, minus 8, and minus 4 plus 2 gives us minus 2. So here I am taking factors like this: minus 4x, minus 2x only I am writing as minus 4x plus 2x minus 8. So x if we take common, x minus 4 plus 2 if we take common, x minus 4. So x minus 4 is common, x plus 2. This if we equate to 0 now. Actually here in place of x we have to substitute some constant k. Later we have to equate to 0, but directly here we are considering. So x minus 4 equal to 0 or x plus 2 equal to 0. So x is equal to plus 4 or x is equal to minus 2. So this we can consider as alpha, this we can consider as beta. Now let us find the sum of roots alpha plus beta. 4 plus minus 2, which is nothing but 4 minus 2, 2. Now alpha beta means 4 into minus 2, that is minus 8, which are same as the values we got by the formula. Like this we can verify the relation between coefficients and zeros of any quadratic polynomial. Now we found zeros of the polynomial when polynomial is given till now. When a polynomial is given, we verified the relation among the coefficients and zeros of the polynomial, and we found zeros also to verify them till now. But if zeros were given, how to find a polynomial? That actually we completed in the previous process only. While finding the relation among these coefficients and zeros, we already, let us take alpha comma beta are the roots, are the zeros. Let alpha beta, let us let alpha beta be the zeros. Then if we take x minus alpha into x minus beta, and if we multiply, already we got previously as x square minus alpha plus beta into x plus alpha beta. This is only the polynomial when alpha and beta are given as the zeros. So this is the formula to find polynomial when zeros are given. But here if alpha beta are integers, then directly we can substitute here and we can get a monic polynomial. Here everybody can observe that x square coefficient is 1. So this is monic only. Whenever we have fractional values for alpha and beta, then we can get polynomial in this way. Previously we got already ax square plus bx plus c by a. Previously with an example we did that we got 3x square plus 4x plus 1 by 3. So in this form we can get the polynomial if alpha beta are rational numbers, that means fractional values. Otherwise if they are integers, directly we can get the answer in this form normally as a monic polynomial. Even this also, even if we have fractions for alpha beta, in the form of monic polynomial also we can get the value. For example, you see this also, first we got like this. Suppose alpha is 1 by 2, beta is 3. If we have, then x square minus of 1 by 2 plus 3 into x plus 1 by 2 into 3. So this is minus x square minus of 7 by 2 into x plus 3 by 2. like this, if we stop without taking LCM, we can have answer in monic polynomial also. So this is the formula anyway to find polynomial when zeros were given. If alpha, beta zeros were given, this is the formula to find the polynomial. Let us practice some problems basing on this formula also.